Right, so we are doing a question in complex numbers, and yeah, this is question number 40, 20 marker. We've been given a function y equal to cos theta plus I sin theta, and first we need to show that dy d theta is equal to iy. It says I may be treated in the same way as a real constant. So if we differentiate this, first derivative we can do with respect to, so first let's write, first we have that y is equal to cos theta plus I sin theta. So if we differentiate this with respect to theta, we get negative sin theta, right? And of course this becomes plus I cos theta, right? I is taken as a constant, so differentiation of that is just taken away. So it's just differentiation of sin theta that becomes cos theta, right? We can, let's write this in order. So this becomes I cos theta plus minus sin theta. Now since you see a minus 1 sin theta, we can probably do one thing. We can take uh, I common here and write cos theta. And since we know that I is square root of negative 1, so I square is negative 1. So what we can do is we can put a plus I here, because I times I will give us I square, which is negative 1 sin theta, and that just becomes equal to Iy. So that's the first part. Okay, let's go ahead to the B part. Then it says solve the differential equation in A to show that y is equal to e to the power I theta. So we have got an equation in A part. We got dy d theta, this is B part, is equal to Iy. So assuming again that r may be treated as a real constant, so I'll bring this here and I'll take this down here. So I'll say dy over y is equal to I d theta, integrating both sides. We get ln cos mod y, right? That is equal to I theta plus, and you can say this is some sort of c constant, right? And this one, there will be a constant here as well if you integrate. So if this is c1, this becomes c2. Then what can we do? We can we can take the c1 over there only. So we can say ln of mod y is equal to I theta plus, let's just call it c dash or cf or something. So now if we change this to exponential form, so we can write e to the power I theta plus cf is equal to y, right? So this can be written as e to the power I theta times e to the power cf, that's equal to y. Now what can we do? Let's go back. Do we have any initial condition? We can see what happens. We know that we have this, right, y equal to cos theta plus I sin theta. So what will happen if theta becomes equal to 0? Okay, so if theta becomes equal to 0, so theta is equal to 0, then in that case what happens? So then y becomes equal to 1, right? So what's happening in this case is if you make theta to be 0, because why will y become 1? Because y is equal to cos 0 plus I sin 0. And of course this part will become 0, so yeah, y becomes 1 in that case. So e to the power 0 will become 1. 1 times e to the power c of f becomes equal to 1. That means that you can say that that's only possible if cf is also equal to 0, right? Because e to the power 0 will make it 1. So therefore, we can write our function again as e to the power I theta plus 0, or we don't have to write 0, so that's equal to y. That's my second part answer, I think. Yeah, okay. Use this result to deduce de Moivre theorem. Use this result, okay. So we have de Moivre theorem that to deduce it. For example, so now if I do to the power n, both sides. So let's say in C part, if I do both sides to the power n, then what happens? It becomes e to the power I n theta, right? Which is equal to, and y was equal to cos theta plus I sin theta. Cos theta plus I sin theta. And of course, if you want to change it to, so if we have reduced that this will become nothing but, in Euler's form it becomes this, but in polar form it would be that only, right? It would become cos n theta plus I sin n theta. So what we've done is we have done this to the power n, and that is equal to the Euler form of the de Moivre theorem proved. So you can say that this becomes nothing but cos theta plus I sin theta to the power cos n theta. The left hand side you can write like that, cos n theta plus I sin n theta, right? So that is equal to this right hand side, which is cos theta plus I sin theta to the power n. So that your teacher doesn't get confused. If you do any rough calculation, that time only just close it. Okay, then there is the D part to the question. There is saying that, what's the question? It says, given that sin 6 theta is over sin theta is equal to this, where sin theta is not equal to 0, use de Moivre's theorem with n equal to 6 to find the values of constant a, b, and c. Okay, what? There's a sin 6 theta over sin theta, and this is what it is. Sin theta cannot be 0, so denominator cannot be 0. So we use de Moivre's theorem with n equal to 6. Okay, constants a, b, and c. So this is a different question only. I don't think this has anything much to do with the earlier one. Okay. Change this again into some other color. Probably. So D part. So given that sin 6 theta, so sine of 6 theta over sin theta is equal to that. It is given a cos to the power 5 theta plus b cos cube theta plus c cos theta. So let's derive it. we say it's put it as n equal to 6. Use De Moivre's theorem with n equal to 6 and get this. Okay. So let's start fresh. So let's say cos theta plus I sine theta to the power 6. Okay. That gives us cos 6 theta, right? Plus I sine 6 theta. Okay. Now we need to, I believe, considering how many marks this is, I'm understanding that maybe I need to do binomial expansion on the left side. So since we are only concerned with the sine elements, let's try to focus on only the imaginary part. Okay. So in the first case, there will not be any imaginary part. 6c0, there won't be any. So we'll start with 6c1. 6c1 cos theta to the power 6 minus 1, right? And times I sine theta to the power 1. Okay. Plus 6c2 cos theta to the power 6 minus 2, and then I sine theta to the power 2. Plus 6c3 cos theta. I'll just quickly write this so that it is as quick as possible. I'll just do the expansion here and here. 6 cos theta. 15 cos to the power 4. 63. Simplify into 4 over 6. 20. So 20 times cos cube theta. Plus I cube. I cube is nothing but minus I think. So minus 20I cos cube theta sine cube theta. Okay, and then finally 64. Continue it over here. 64. So 64 is the same as 62. So it's going to be 15. So 15 cos square theta. So I square is negative 1. Negative 1 times negative 1 becomes positive 1. So 64 is this time 15 plus 15 cos square theta sine to the power 4 theta. If you notice over here, wherever the powers are even, you can skip those and you can go straight to the odd ones. So let's just focus on this. 61 is the same as 65. So 61 is 6 cos to the power 5 theta. Okay. So clubbing only the I terms together. This one was 6I cos. So we have, for the I terms, we have 6 cos to the power 5 theta sine theta. We have minus 20I, forgot the I here, sorry, 20I cos sine theta. Go to the odd power, number 1 odd power, 65. So 65 is cos 6 cos theta, 6I cos theta. That's I times I to the power 4 is 1, right? Times I again is this I. So that's plus 6I cos theta sine to the power 5 theta. Plus 6 cos theta sine to the power 5 theta. Okay. So that's the expansion of the imaginary part. And this side, all of this is equal to sine of 6 theta. Right? So this is equal to sine of 6 theta. Right? So now they're saying that if we divide all of it by sine theta, so let's say we divide it by sine theta, what will happen? This sine theta will go. I'll write that on another. So sine 6 theta over sine theta is equal to 6 cos to the power 5 theta minus 20. We won't keep the I term here right now. We don't need it now. 20 cos cube theta. We'll cut it by 1 sine theta, so sine square theta. Okay. Plus 6 cos theta sine to the power 4 theta. That's what we get. And what are we supposed to prove? Let's just go back to the question again. We have to get everything in the form of cos. Okay, so then let's quickly write. It's 1. This sine square theta is 1 minus cos square theta. So you can see that we've got one of the coefficients which we've got. A is 6. We've got A is 6. So cos cube theta. So basically 1 minus sine square theta. 1 minus cos square theta. Square theta plus 6 cos theta. So sine square theta can be written as sine square theta whole square. So 1 minus cos theta, cos square theta whole square. No wonder this is 10 marks. Okay, 6 cos to the power 5 theta minus 20 cos cube theta, okay, plus 20 cos to the power 5 theta, okay, plus 6 cos theta. No, wait, let me just expand this. We have 1 plus cos to the power 4 theta minus 2 cos to the power square theta. It becomes this and this can be added, so it becomes 26 cos to the power 5 theta minus 20 cos cube theta. Let's continue with this. This becomes 6 cos theta plus 6 cos to the power 4 theta, cos to the power 5 theta. Okay, and 6 minus 2 is minus 12 cos cube theta. Finally, I get 26 plus 6 is 32 cos to the power 5 theta. Okay, minus 20 cos cube minus 12 cos cube is minus 32 cos cube theta. So this is done, and plus 6 cos theta. Yeah, I think we're done. Right, so we've got this. We're getting a plus. So find the values of constant a, b, and c. So a, b, and c should be nothing but 32, negative 32, and 6. A should be 32. B should be negative 32, and C should be 6. Let me just cross check this once. Yeah, yeah, that's what it is. So A is 32, B is minus 32, and C is 6. Those are the answers for this part. I think this should be 7 or 8 marks. Then the second part is reduce the value of limit theta tending to 0, sine 6 theta, sine upon sine theta. So basically, limit, we have to just put limit theta tending to 0 on this. Limit theta tending to 0, 0. So that cos 0 becomes 1. So all of this will become 1. So 32 minus 32 plus 6, answer is equal to 6 for the D second part. Yeah, I think this should be just 2 marks.